Welcome to the Databricks Skill Builder series. We're glad you're here.
Awesome. So again, my sort of baseline assumption here for everybody on the call is that we are familiar with Terraform basics and kind of know where those docs are. If not, if that's a bad assumption, please please let me know. I'm happy to give a quick overview of that as well. I wanted to start
Real quick.
Yeah.
Also, just those on the line, if you missed the first session, feel free to let me know in the chat and drop your email in there, and I can email you the first session. And then you will get this session in your email after it's over. So you have the option to watch the first one if you missed it.
Yes, thank you. Okay, so Terraform registry. Under the Databricks namespace, there's the provider, right, which contains links to code and docs for the Terraform provider itself. But we've also got some modules that have already been published here. And most of these modules are intended to be really jumpstart sorts of modules for various different focuses. So many of these you're going to see right now are all about running an ML ops stack, either on AWS or Azure. There's more in here if you click on view more, and you can see some of these things that have been published. Two of particular note I want to call out are the Lakehouse, what do we call this, module, I guess, and the Blueprints module. And I'm going to walk through a couple things there. This examples module contains a bunch of different types of things you might want to do across cloud. And these all have their own documentation, and they're split into modules and examples. And they've also got handy dandy little GitHub link. So you can kind of consume these from either place. Really kind of depends on your preference. You can kind of get back and forth pretty quickly. They're sort of circularly linked, so it's hard to get lost. But I want to point these out and make sure everybody knows that these are here. They provide quite a bit of sort of getting started helpfulness. So if you haven't worked with Private Link on Azure, for example, you can click into here and it will give you a whole full example, not only of the architecture, but code to build these things via Terraform. So if you are familiar with Terraform, you can see, fairly standard stuff going on here as far as setup and piping. But the main interesting stuff, right, is going to exist in the particulars. So let's say we want to stand up our VNets. So you can see all this stuff filled out for us, including security rules on the networking side, building our subnets and delegating to Databricks resources, all these sorts of things that you would have to normally go do by yourself. We've got some accelerators here in the examples repo. So want to point this out, make sure everybody knows it's here. In general, I wouldn't recommend starting totally from scratch. There's quite a bit in here that'll get you pretty far down the road. So I want to make sure we're aware of these. For the other thing I'll point out at this point, just real quick, is the Lakehouse Blueprints repository. Now this repository has some infrastructure examples in it as well, but of particular note, there's some solution accelerators that you can pull in if you are, for example, in financial services or health and life sciences. We have some solution accelerators built in here that you can automatically leverage as well. I think I've got a question and I'm hearing somebody saying something, so I'm going to pause.
Sorry. They're asking for the repository link to be put in the chat.
Certainly. Jump it up one. Actually, this is probably the most helpful thing because this will link you to all of them. But I'm going to put the registry. I could click on the chat. Registry is going to go first, and then this was the examples repo, and I'll post that one here as well. Yes, where was I? Okay, so that's the first thing I wanted to point out, is that these resources exist here. Want to make sure we've got them. Good call out in the chat. So we've got those too. Does anybody have any questions on these examples, or, like, does this make sense, or is this like a why would I care sort of a thing? I want to make sure we're on the same page here so far. Seems like yes, but just offering up double opportunity. Okay, I don't see anything. I'm going to move on. One step further, often once folks that are using Terraform for Databricks have configs that are working for them, whatever it is they want to be doing. For arguments, let's say we were setting up this private link setup we just looked at with the standard deployment, this sort of an architecture. Oftentimes, there then comes the question of, okay, great, I know what I'm deploying, I know I can automate it, but how do I hook that into my overall change management process or CI/CD, things like that? So I just wanted to make sure that I pointed out that Terraform has built-in GitHub Actions produced as well. So you can actually hook in, running Terraform commands, whether that would be, an apply. I've used this GitHub action, for example, to stand up an integration environment, for dynamic testing and allocation of cloud resources, things like that. Many, many, many things are possible with really just the composition of two pieces of technology, right? The GitHub Actions and Terraform code. So I wanted to make sure everybody was aware of this. Not many people that I've worked with Terraform on Databricks are directly leveraging Terraform with GitHub Actions. So I wanted to make sure that I did a little bit of enablement and education that this stuff does exist, because it can be pretty powerful. One thing to note, I'm going to link this as well in the chat real quick. One thing to note about the Terraform GitHub action, the setup Terraform action as it's called, is that it assumes as a prerequisite that you have Terraform Cloud. Many people that use Terraform that I've worked with anyway are mostly using the Terraform CLI just on their local machine, or installing it on a VM somewhere. But don't be scared of Terraform Cloud. Terraform Cloud is pretty cool. And this doc walks you through everything you need to know to get started. But if you haven't looked at Terraform Cloud and haven't evaluated it or haven't used it, definitely would recommend it. At least to take a look at it. It can be pretty powerful workflow combined. Checking, pausing for questions. Good timing. I will see the link in the QA section. Oh, Stephanie. Oh, I think I put it in chat instead of in the Q&A. That could be my Stephanie. Can folks in the Q&A see the chat? I guess I don't actually know.
Oh, I see. So in the chat, you sent it to the host and panelists on accident.
I didn't send it to everybody. I see. Whoopsies. Got it. Thank you. Let me repost those.
I can add it to the Q&A too.
Ah, sure. Yeah, either way, I suppose. Doesn't matter too much to me. Let me grab these. Hopefully this will paste them well. Not really. Okay, one moment. Ooh, that did not work. Okay. Dang it. One moment. We will do it this way. Terraform registry. Examples repo. Oh, that was in a level. Apologies. Here's the examples repo. And GitHub Actions link. Okay, perfect. That's what I did wrong. Got it. Heard. Where were we? Yeah. Okay. Those are the big major key points I wanted to touch on as far as kind of next steps from, okay, we understand Terraform and we understand, Databricks, and we want to smash these things together. How do we get more opinionated, or are there any things we can bootstrap with? That was the main thrust of the enablement that I wanted to provide from the Databricks perspective. I went through it pretty quickly in case I wanted to leave room for specific questions that anybody might have. I will expand and just say, don't be fooled by the brevity with I ran through all of this. The documentation and the examples in this repo is pretty dense. There's a lot in here. So you can definitely dive in and get a little bit lost, which I think in this case is a very good thing, because it's a bunch of code that you don't have to write yourself, which as long as you've got some confidence in it is always great. And I do also want to call out the CI/CD that I talked about before. There are also examples of that in work within the repo as well. Okay. Yeah, that's the big stuff. Go ahead, Stephanie.
I was just asking the audience, any questions? Do you guys feel like you're prepared to kind of dive into this on your own? Anything you want to ask while you have Nathan available? Don't be shy.
I maybe overscoped the amount of question time. My first session was pretty heavily attended, and there were many questions, so I backed off content on this one kind of on purpose to leave more room there. See one, sure, no problem. If I may be slightly pushy, can you give me a sense of where to start? Like absolute zero, I don't know Terraform, or I've got a sense of the concepts, but what does the code look like hands-on? How do I interpret this stuff? Sorry, I can't say a name. I think the question was anonymous, but whomever it was to ask for basics, if you could give just a slight clarification on at what level to start, I'd be happy to dive in. Okay, I'm just gonna whirlwind through and narrow me in where necessary. Couple of things, I guess, to start. We can cover one project and try to implement it. Okay, sure. That works for me. We can start there. Let's say we wanted to do a basic thing and deploy an Azure Databricks workspace on Azure. And let's say we wanted to do that via VNet injection. Now, if you're not familiar with VNet injected Databricks workspaces on Azure, to give you a quick sense of this, there's two main ways to deploy a Databricks workspace on Azure. One of which is to kind of just use default settings and have everything be managed. The other is to specify networking yourself and deploy the Databricks workspace into a pair of subnets defined in a VNet. Allows you to configure things like custom DNS, firewalls, leverage service endpoints, private endpoints, etc. So this is often the route for most of our customers that are interested in like a bit more robust security. Often our regulated industries customers are exclusively deploying in this fashion. And sorry, my Zoom thing, I can't see the top of my screen. There we go. Okay. So that's VNet injection in a concept, basically deploy in your own networking configs. Now, when it comes to getting started, probably the easiest thing to do would be to just clone this repo and pull all this code in and run it. Now, to do that, why don't we just go ahead and do that for argument's sake? Why not? We've got some time. What could go wrong? Live demos. We'll put this over here, I guess. Okay, let's go. And we'll do it. And if there's questions here, again, feel free to be chatty. Oopsies. Managing the Zoom meeting on the Windows is tougher than you think. Actually, since I've already got one, maybe I will, where do I have them? Let's go to, no, we'll just go on. Let's do that. Uh-oh. What? Oh, geez. Okay, I'm not gonna mess with this right now. Let's go to so in this case, I've just gone into, I'll show you. I already have this repo cloned. Lakehouse blueprints. So if you believe me that that's the case, I'm going to give you an example of basically the same thing. Okay, so say we did this and we pulled this code down. You would end up with something that looks kind of like this. And one thing we want to look at typically first is often I guess, actually, no, we don't need to open this whole thing up. Let's do providers. So one thing to keep in mind with Terraform is that it's very largely convention driven in terms of your Terraform files themselves. You can name them anything so long as they're in a .tf file name, like we got that suffix, and they need to be within a directory. Is how Terraform organizes things, but you could have everything in a single Terraform file that's called, I don't know, banana.tf, something not helpful at all. Couple of conventions to pull out and specify what providers you need. So in this case, in this file, we can see all of the different Terraform providers that are required. In this case, we just need Azure RM. Similarly, variables are pulled out into a separate file. In this case, partially for the sake of documentation, but partially for the sake of self-discovery and example, we've included descriptions of all of the required variables. Similarly with outputs, I like putting those in a separate file as well. And just as a refresher, outputs are things that will, when Terraform is run, when things are applied and planned, will be output to console. In the case of modules, they are also the way that you can pass information from a child module to its caller. So let's take a look at the main file. Actually, for this one, we are going to open it up all the way so we can get a little more real estate here. Let me, oops. What just happened? I guess I killed my terminal. Sorry about that. Yeah. Okay. So here we are with our main. Okay. So if you
or terminal, we only see the sign into Databricks.
Oh, I must be sharing the wrong. Let me share my entire screen. I think I was only sharing the window. Thank you. So none of the things I'm screwing up matter. I'm just talking at air. Okay. Now are you seeing my terminal?
Yep, good to go.
Okay. Sorry, I was describing these things. Let me back this up so you can see what I'm talking about. Providers file. In this case, we see two providers, Databricks and Azure RM. In this case, because we're standing up hub and spoke, and we want to authenticate to do things inside of a workspace, we're passing some information to that provider. I also mentioned the variables file as convention, and I talked about the outputs file. So here you can see, trying to follow some reasonable naming conventions, be able to reference these things later. But those are the things that I was demonstrating, I guess, to nobody because I wasn't sharing the right thing. So hopefully we're on the same page there. Let's look at the main. I want to walk you through this. By convention, single file Terraform projects are often named main.tf. I tend to reuse the convention of main.tf, sort of like a main method, right? To hint to people that that's where we should look for like the main plumbing, the main flow of whatever we're doing. So in this particular case, to give you a sense of what's going on, we're deploying a hub and spoke architecture. So we need to deploy both a hub and, in this case, a spoke. Could be multiple spokes. You can for each over modules. So that's one way that you can get easy. What do you want to call that? I don't know. You can deploy one or many of a thing, basically with Terraform's version of a for loop. But in this case, the way you would read this is anywhere you see resource, that's defining some infrastructure somewhere that Terraform is going to manage. So keep in mind, this is on Azure. So we're setting up a resource group for our hub resources. We're building a virtual network in it. And then we're doing something with this module called Spoke VNet and Spoke Databricks Workspace. Now, it may not be obvious what we're doing unless you go look at that module code. But I'll tell you. So this Spoke VNet module exists to build out another VNet and handle peering relationships with the hub. And the Spoke Databricks Workspace module, in this case, exists to deploy a Databricks workspace inside of this Spoke network that we've created. And this Unity Catalog module, as you might guess from the name, is responsible for deploying Unity Catalog. It also is responsible for associating this workspace that we are expecting to be created with the Unity Catalog metastore that this module will create. I don't see any questions, so I'm going to keep barreling right along. So the way in which we kind of look through that file is the same way you could do with any of these. I think READMEs and documentation is helpful for this kind of stuff. But in essence, if you go and find every resource block, that'll tell you all the infrastructure that Terraform will manage. Now that means, of course, both. If it doesn't exist, it's going to assume it's going to try to create it. If it does exist, it's going to try to make sure that if it does basically a diff between the configs, that it makes whatever changes are necessary to arrive at the right-hand most or the newest state. In this case, I've pulled out firewall information into a separate Terraform file. It's less than 100 lines, but all of these things are conceptually related. I didn't feel like it made sense to modularize them. So to give some sense of code modularity, not necessarily Terraform modularity, I just broke it out into a separate file. And that's something that, I'm sure people are opinionated on. I find that to be helpful from a readability perspective. Now, in this case, I was deploying this recently. I don't know if this one's ready to go from a live demo perspective, but I'm going to find out. So we're just going to try it, and it might break. And I think that is at least as illustrative as it working for the purposes of how might we get started. So first thing we'd want to do is run Terraform init. And this is going to go and pull in the providers that we said are required. And it's going to make sure that any modules, providers that are called out in the config are installed and ready to use. Now, in this case, I'd already had one running. I was running this for example's sake. In this case, we've got a bunch of information about we're reusing previously installed things. We didn't download stuff because we already had those dependencies downloaded. We'd already run Terraform in it, but now you can see that. Another thing I do frequently is the Terraform format command. Apparently my variables weren't formatted, so there you go. I input variable file. That's like it's just like a linter built in basically with Terraform. So it's going to opinionatedly format and rewrite your file so that everything's standardized that way. Definitely wouldn't recommend including that in CI/CD pipelines and the like. And then the next thing we can do is run Terraform validate. If this breaks, yeah, okay, we're going to have big problems. So validate is, think of it sort of like a compiler. It's going and actually parsing through the config that you've written in these text files and making sure that prior to actually executing any API calls whatsoever, that your config makes sense, like you didn't miss a curly bracket, or it's also able to check for some dependency type things in the language, in the configs themselves. So it's a good thing to run that. It's going to be quicker than a plan, for example, which is the next thing we're going to do. Now, Terraform plan is the stage at which Terraform is going to take a look at the configs, and it's going to parse through them. And if previously existing state exists, if you've run this thing in the past, it's going to go ahead and basically do the diff and tell you what it's going to build. So in this case, you'll see it spat out a whole bunch of stuff, and I'm going to scroll up here in a second. But the main thing to note, I guess, at first glance, is down here at the bottom, where it's going to tell you what the results of the plan are. So it's sort of cruddy if you're familiar with CRUD apps in that sense. So we've got a section for things we're going to create, we've got a section for things we're going to change, and we've got a section for things we're going to destroy. Depending on current state, when you run a Terraform plan, these things might look very different. And I'll show you a couple examples. Outputs we mentioned before are here. So these are some of the things that this example outputs. So when it, in this case, I've got outputting names of some things along with the workspace URL that it creates. In this case, we don't have one because we didn't actually run apply. We just did a plan. So no action has actually happened yet. So it can't tell us what that is because that's a dynamic thing. Post apply, that would be output though. I'm going to scroll up for the plan. There's quite a few things in here, 40 resources. So, but I want to give you a sense of what this looks like. Okay, so Terraform does spit out some very helpful terminal things, give you a sense of how to read the legend. And it goes and spits out all of the resources it says it's going to build and gives you essentially their parameters where known, very similar to what we saw at the bottom. So this is very useful for getting a sense, just like a git diff, of what our operation is actually going to do for us. And there's a whole lot of this in here. I'm not going to super zoom into it. It's essentially going to be identical to what's in the config itself, essentially. I hope that all makes sense. Again, feel free to be liberal with questions. Don't see any, so I'm going to continue. The next thing that we would do if we wanted to build this, in this case, let's say we do, and I don't know if this is going to work. Since I'm sharing, I'm not going to open my credentials files or anything right this second. I'm just going to run it and see what happens. It might blow up. Since I just did a plan and I haven't changed anything, I'm going to go ahead and use this auto approve flag, so I don't have to type yes and hit enter after it does the plan again and then asks me if I want to actually do it. So I'm just going to tell it to do it. And yeah, again, live demo. So I don't recall which internal Databricks environment I told it to go deploy these things to. I'm just going to run it and see what happens, because I think that might be more fun. We've had a lot of internal resource changing, so it's entirely possible that this is going to be pointing at an Azure environment that I don't have permissions on anymore. So it might blow up. Ooh, doesn't look like it's blowing up. Looks like I'm building 40 resources on Azure. So great, we're going to get to see what this looks like, at least to some extent. I see a question while this is scrolling and running. Utam says, sometimes when we delete a few existing resources, without destroying them, we rerun our pipeline, it fails, saying the resource is orphaned. Yeah, so there's a couple things you can, the question was, what's the best way to deal with the situation? So there's a couple things. It depends. I would say the first and foremost with stuff like this, the ultimate culprit usually isn't technology. It's usually like organizational change management and change management processes that kind of define the tech stack or the tools or the phases. So for example, one thing I would suggest is if you're using Terraform to own infrastructure, and I realize this might sound very silly and reductionist, but genuinely, if you're using Terraform to manage infrastructure, don't allow people to manage that same infrastructure manually. And I know that's not always possible, but fundamentally, having a hard line there often helps a lot. Just don't let people manage them individually, and then you can't get divergent. However, this all happens anyway. Typically, the best way to handle things like this are to leverage Terraform state manipulation commands, and I can link some of those, but fundamentally, I will show you. So there's a whole section in the Terraform docs on state, and there's a couple of different I would say details, like ways in which you can manipulate state, you can mess with it when things get screwed up, you can remove state, etc. And there definitely is talk on here in scenarios where you've orphaned resources, things like that. I think probably the big one, if you're not aware of, is on import. So often what will happen is you'll have state where, for example, say we've gone and defined this whole config that we're deploying. I lost my window over here, right? What if, for example, my organization dictates that for whatever reason, I'm not allowed to deploy networking resources, but I'm allowed to deploy a Databricks resource given networking resources. Okay. That might be an example where I go download this thing and I go, this is great. Yep, I've got, I've got my VNets, I've got my subnets, I'm ready to go. In this case, Terraform's going to say, hey man, that VNet you referenced, or that firewall you referenced, that name, that firewall already exists. So what do you want me to do about that? In the instance where the answer is, yes, I know, that's great. We want to take that firewall and we now want to manage it with Terraform. That's where import comes into play. It's where something already exists, but you do want Terraform to manage it. The other thing you can do, well, let me think about that. Yeah, no, that's really the case where something already exists. In the case where something was deleted and Terraform's mad about it, you probably need to either mess with the state or avoid that happening. If that makes sense. Like the first case where I said, try to separate those things out and don't allow manual edits to Terraform managed resources wherever possible. Not always possible, but oftentimes if you're leveraging Terraform for infrastructure deployment, the person that's doing that is very close to the keys, metaphorical keys, at the platform or the central IT level to be able to enforce things like that. Does that help at all with that question? Oh, hey, you did stuff. I hope so. Okay, if not, let me know. Meanwhile, it looks like our apply worked, which is fun. Let's see if we can log into this Databricks workspace. I hope so. This is the best the random demo has ever gone for me. So let's see what happens. So this is the first login of anybody ever. So I would expect that this would take a second. And looking good so far. Huzzah! So there you go. We went from 0 to VNet injected Databricks workspace, believe it or not, with a firewall and everything. And well, 4 minutes and 14 seconds plus some blabber. So I guess like if you're totally brand new to Terraform, what we just did actually should probably be a little bit mind-blowing, and I'm not being facetious at all. As somebody who's had to run around and build stuff like this manually through the Azure portal quite a bit, what I just did would have taken me, like current me, not past me learning things, current me, easily an hour, just clicking through, the menus and stuff. But anyway, let me see where Want to make sure this is discoverable this way too, so I can give you a sense of what's going on. Excellent. Okay, so I'm going to, just as a kind of a proof point here, the Azure Databricks, man, I really hate this menu bar. I can't see my tabs. Okay, sorry. Anyway, this Azure Databricks workspace that we built is hub RG. Oh, right, we're in the hub. Sorry, ignore that. We'll get to that. So the firewall we talked about, and the firewall policy that we built, and that hub VNet, and all of those good things that we see here, is what we went and built. So yeah, I guess we ran code and things got produced in Azure, which I don't know, I think is cool. Maybe not mind-blowing, but kind of cool to see it happening live, I think. Yeah, so an example, firewall policy, we've got our rules just showing that these did get applied. So in this case, we have rules to allow access out from the firewall to hit like PyPI and CRAN and IP info. So we can do those sorts of things. Organizational policies differ. You might not want those things. You don't have to have them, but I think you get the idea. Okay, sweet. So we stood some stuff up. We've got a Databricks workspace. I can do stuff with it. Let's say in this case, I wanted to, what would be a fun thing to do? Let's say, for argument's sake, that I wanted to rename my hub VNet, let's say. Maybe now, and there's a bunch of different ways I could change, variables here. Typically, I wouldn't recommend just going in and changing the default to do these things. But I have some sensitive data in my variable file, so I'm intentionally not opening it just to simplify things. So for this hub VNet, for argument's sake, we're going to do this. We're going to say that we now want our hub VNet to be called hub VNet-change-me. So if we now do a Terraform plan, we're not going to see, and I'm going to make this bigger again. Okay. We're not going to see the same thing we did last time. First of all, we see we're refreshing some state. So that's great. We're going to go, in this case, well, doesn't matter. This is literally a random string generator for uniqueness. So we're going to check our state. We're going to hit our API calls. We're going to compare them in reads to our state file. And we're going to, perfect, I broke it. Why did I break it? Oh yeah, because it's looking for hub VNet, the hub VNet to be named hub VNet-change-me, which it's not. So this is a good example actually of that previous question, I think, in a way, where what happens if let's say the VNet I was expecting is actually hub VNet-change-me. In this case, what it did is it went and looked within this resource group and it says, hey, this VNet doesn't exist. So in the spoke VNet, it's expecting this to exist, and it says it doesn't. If it did, this is where I would run a Terraform import, if I could type correctly, to import change-me. In this case, it doesn't exist, and that was a very silly change for you to make because that doesn't do what I want it to. So I'm going to undo that change, but you get a sense of kind of how that workflow would work. Tom, I see you've asked further when I'm trying to create the cluster using cluster CID. Okay, sorry, let me read this out loud. What I was observed when I was trying to create the cluster using Terraform, running the CI/CD pipeline, it was again creating the cluster with the same name, but the cluster ID was different. What we got answer is the API, which is exposed by, okay, apparently there's a provider issue maybe. I don't have an update on that particular issue. I'm not aware of it, but what we can do is go back to our registry and let me look at the provider. I'm going this way just so it's extra clear how I got there. And let me see Oh, I do have to sign in. Come on. Yeah, I just want to see the issues. The Terraform issues, GitHub issues are the place to open those. I'm not sure about this particular. I'm not going to be able to give you an exact answer on this one because I don't know what the issue number is, or if you've got a support ticket open or something like that for it. So I'm not sure, but it's very possible that there's a bug here. It's creating a cluster again with the same name. Yeah, I'm not sure. Sorry on that specifics. I'd have to get a little more info. But yeah, let us know if you've got a particular, if you know what the issue is, or you've got an open ticket or something like that that needs to be pushed. Let us know. I can do what I can to see about that. But long story short, GitHub issues on the provider page are where a lot of these things will be tracked. Production support's different, but in terms of issues with the provider itself or feature requests, that's the main place to go. Okay. Did that. Right, ran plan again, no changes. In this case, to be a good steward of my demo environment, I'm going to go ahead and run destroy. That's a command we haven't looked at yet. It is kind of the opposite of apply. In a way, it is an apply, but it's a very specific kind of apply that says whatever you've built or whatever you've said to be built, where it exists, make it go away. So it's the finalizer, it's the undo, it's the tear down everything button. So pretty much identically to a plan or an apply phase. We're comparing state, and we're in this case going to get the opposite of our first plan, where we had 40 things to add and everything was green plus marks. Now we have 40 to destroy and everything is red minus signs. And it nulls our outputs because these things won't exist. This is the step I skipped before, excuse me. When I used auto approve, you can do that with destroy as well. In this case, I didn't because I wanted to point out that the essentially the results of the plan are different because we're blowing stuff up. Say we're trying to create a cluster policy using Terraform. CI/CD's already created the cluster policy for us. When we run the CI/CD pipeline a second time, will it fail or will it succeed? What should happen, what I would expect to happen with cluster policies or anything else really, is it will essentially be a no op. So like we saw the second time I ran the apply, it said, hey, there's no changes between what you've defined in your config and what's in your state file, what exists. So it won't do anything. It should be a no op. Terraform will run, it'll compare states, and it'll say, yeah, we're done, complete. It matches, we're done. At least that's what should happen. So it's designed to be idempotent that way. So it's sort of like a git diff in that sense, right? If you run a diff and there is no diff, it'll output nothing. So very, very similar intended semantics anyway. Again, caveat for it's entirely possible that there's something in the CI/CD pipeline that's executing in a way that I wouldn't expect. And it's also possible that there are, bugs or edge cases in portions of the provider or somewhere in cloud functionality or something, right? I've certainly seen things like that could be impacting it, but from a design and intent perspective, it's designed to be idempotent. And again, just to go full circle on that, that's through the state file and basically interrogating it and comparing it with the cloud provider, in this case, API calls for current state. Good questions. Okay, so not super exciting. Yeah, no worries. Anytime. Not super exciting what's going on screen here. It's blowing up all the stuff we just built. And this can just, I guess, as a what do I want to say? Probably unnecessary explanation, but in this case, of course, this is running locally, in my terminal session. But fundamentally, this can run really, anywhere that Terraform CLI can be installed that has, internet access to hit the API endpoints that you're asking it to. So this could have been running on, Terraform Cloud, for example. This could be running as the result of a GitHub action. It's going to work pretty much exactly the same way. Just to be clear, that there's tons and tons of flexibility there. I've actually had customers in the past request to have Terraform run from within a notebook on a Databricks cluster. That actually works too. You can install Terraform CLI on like a Databricks cluster node, for example. So I've actually used the Terraform exporter to produce like little backup and restore functionality, essentially, that can be scheduled within Databricks to run. So it's sort of fractally, because you're running Terraform from a Databricks cluster, and the results of running that Terraform command might change the notebook itself. So it can get a little weird, but it's very powerful. So lots of flexibility there. Okay, well, this is gonna destroy, and I can't think of any reason it would fail. So there's nothing exciting coming here. We're just blowing up the stuff that we built. There's no great reveal. So I don't recall, it came up as anonymous, and this whole rabbit hole I just went down, I believe was brought up because somebody had asked for a question on kind of the basics. I want to make sure that I'm doing some due diligence and circling back. Whomever asked for that question, did this cover any of the important? Well, I don't want to say any. The important stuff. Is there anything remaining that you're like, hey, that's all great, but I'm missing this nugget? If so, let me know. Happy to recorrect and get there. Meanwhile, this is gonna destroy our stuff, and then I'm gonna send you all to lunch, hopefully a couple minutes early. Or whatever else it is you're doing. I'm not in charge of you. Do whatever you do next. Doesn't have to be lunch. For me, it's lunch. Stephanie, any thoughts, questions maybe on your end while this is wrapping up? Or should we cut everybody loose 6 minutes early?
I think it looks good to me. We don't have any other questions, and really appreciate your time today. We'll let everybody go. Have a great day, everybody.
Have a good one. Thanks for your questions and participation. If you really want to watch this thing destroy itself, it's gonna destroy itself. So if anybody wants to see it, speak now. Otherwise, I think we'll stop sharing. Nobody wants to see it blow up. Okay, great. Stopping my share. It'll blow up eventually. Firewalls take a minute to tear down. Okay, I'm gonna quit blabbing and go eat some lunch. Thanks, everybody.